Hello everyone, welcome to ClassFly lectures. Now let's talk about line integral, which is integral over c. C is the curve f of xy dr, and f of xy is a surface in xy plane. Okay, this is the f of xy. We have the x-axis over here and y-axis over here. Then consider a xy plane where the f of xy is 0. Here f of xy is 0, right? The value of f of xy is 0. Then another surface where f of xy has some value. Okay, this is that surface. Let's take a surface f of xy which is not a plane, which is like this. It is coming downwards and then going upwards. So if you can't imagine this one, consider a lots of sine curve. This is a sine curve, right? So this point is here, okay, and here we have a line. So infinite numbers of sine curves are adjacently placed up to this point, right? So we get a plane over here like this. Okay, we get a plane like this. Now consider a curve, our curve C, which is, this is our actual curve. Then integral over C f of xy dr indicates the area under the surface and the curve. Okay, the curve is moving like this, and the surface is moving like this, and the curve in this plane is like this. So we have to take the area of the wall formed by these two curves, right? You got the point? So we will get a wall like this, right? A wall, and integral over c f of xy dr gives area. Now let's talk about another concept, work done. We have work done, W is equal to force into displacement, which is force in actual vector. The vector form of work done is F dot D, which is equal to F into D into cos theta, right? If theta is equal to 90 degree, work done is equal to 0. If theta is equal to 1 or 0 degree, then work done is maximum. This is the basic concept. So force into displacement, which is F into x2 minus x1, which is the work done. Okay, I am pushing this one until it gets to some point x2. This is a plane surface. There is no always theta is equal to 0 degree. The theta is the angle between force and displacement. Okay, so here the force and the displacement are in the same direction, therefore theta is equal to 0 degree. Then integral dw, first one, dw is equal to, let's assume a small distance dx. So if I push this one and it moves a dx distance, then the work done, the dw is F into dx, right? Then integral dw, which gives work done, is equal to integral F dx. So we got the work done. W is equal to integral a to b F dot dx, which is, we are considering a small length element dx, and when we push this amount of distance with a force F, the dw is F dx. Then work done will be integral a to b F dot dx. Another concept of integral, this is simply an integral over c, and when this is a curve in this condition. What if the curve is a closed one? You see that this curve is completely closed. In this case, the integral over c f of xy dr turns into closed integral. This is closed integral f of xy dr. This is just a concept. If the curve is completely closed, then we have to write closed integral dx, and this is a condition when closed integral over c f of xy dr is equal to 0, then this vector field is an irrotational vector field. Okay, this is just a condition. You have to by heart this one. For more videos, visit ClassFly.in.